this is the continuation of lecture 1. Okay, so this is going to be lecture 2. Okay, so in lecture 1 we looked at differentiation of vector functions, and we specifically look at the ordinary derivatives, right? So here we are going to look at the partial derivative of vector functions. Okay, so for instance, if you have a, okay, if a is a vector depending on more than one variable, okay, depending on more than one variable, say, so is if a is a vector depending on more than one variable, say x, y, z, then we can say that we can write a as a equals a into x, y, and z. Okay, so that is when we are talking about partial derivative of vectors. Okay, so if a is a vector depending on more than one variable, then we can say that, for instance, x, y, z, then we can say that a is equal to a into x, y, z. Okay, so the partial derivative of a with respect to x, y, and z is giving us the partial derivative of a with respect to x, y, and z is giving us, we are going to apply the first principle in here. Okay, so with respect to a, okay, it's more than one variable, so it's going to be a partial differential, as the title signals, right? So we're going to have partial differential of a with respect to x, and that will be equal to, so we are differentiating this partially with respect to x. Okay, and we are obeying the first principle. Okay, so we're going to have limits as s, okay, limit as change in x approaches 0 of x plus change in x, then y and z, right? You know that this is from the first principle, okay? Minus a of x, y, and z. Okay, all over change in x. Okay, so this is from the first principle. Okay, so this is from the first principle. And so we have the differential of a with respect to x. So the differential of a with respect to y will be equal to lim as change in y approaches 0 of x, comma, y plus change in y, comma, z minus change in minus a, okay, minus the function of a, that is x, y, and z, okay, all over change in y. Okay, so that is for the differential with respect to y. So with respect to differential of a with respect to z will be equal to limit as change in z approaches 0 of x, comma, y, comma, z plus change in z, right, minus function of a, that is x, y, and z, right, all over change in z, right? So the partial derivative of a with respect to x, y, and z is giving us here, here, and that. Okay, so this is basically from the first principle. So you got to understand that. Okay, so mathematics is basically everything we did from the basic is a stepping stone to higher mathematics. Okay, so now we have the derivative of x, y, and z. Okay, okay, so now this will only work if their limit exists. So that's Thus, if their limits, if their limit exists, this will only work if their limit exists. If the limit does not exist, these things will not work. Okay, so that is basically for um, the how you can differentiate more than one variable. Okay, a function of more than one variable with respect to their variable. So when you consider the function differentiating with respect to a, meaning you are maintaining other functions, other variables to be constant. Okay, so with respect to x is x plus change in x, then you maintain x, y, and z. And also with respect to y, meaning you are maintaining x, then y plus change in y, then maintain z minus the function of a. Okay, so that is basically for that. Now let's look at higher derivatives. Higher, higher partial derivative. Higher partial derivatives. Okay, so higher partial derivatives can also be written as can also be written as can also be written as 1 the squared a with respect to the squared a with respect to s squared, the squared a with respect to the s squared is equal to the x of the a with respect to the x. Okay, so basically, if you have the squared a with respect to this, the s squared is the same as d with respect to the x of the a, the x. Okay, and two, two. If you have the squared a, okay, with respect to the y squared, then you can have d dy of the a with respect to y. So basically it follows in that order. Okay, so 3, the squared a with respect to the z squared is equal to b the z of the a with respect to the z. Okay, so it follows in that order. So now we have x, we have y, we have z. Okay, so that is okay. We can talk about the x dy. We can talk about the x dy. Okay, so we can talk about 4 the squared a with respect to the x dy. Okay, so that is basically the same as d dx of d a with respect to the y. Okay, and also 5 the squared a over d dy with respect to d dy dx is the same as d dy of the a with respect to the x. Okay, so it follows in that order. Okay, so the squared a with respect to the x dy is equal to the x of the a with respect to dy. And when it changes to, you have to follow the order. Okay, so if the function is continuous, then order does not matter. Okay, so if the function is continuous, then order does not matter. If so, for instance, this is a function of a. So if a is continuous, then order does not matter. Order does not matter in differentiation. Okay, so now let's look at some rules that guides partial differentiation of vectors. Okay, so now suppose a and b are functions of x, y, and z, then these rules are applied, or these rules must be followed. Okay, so one, if you have partial d dx of a dot b, then you can say that this is equal to a d a times differential of b with respect to x plus differential of plus partial differential of partial differential of a dot b with respect to x. Okay, so if you have um partial differential of a dot b with respect to x, then it's the same as a times straight differential, full differential, okay, a times differential of b with respect to x plus partial differential of a dot b with respect to x. Okay, so let's look at rule number 2. So rule number 2 is when you're having the cross, okay, so with respect to x, but this time it's not dot, it's a cross b. Okay, so this is also a times differential of a cross differential of b with respect to x, a cross differential of b with respect to x plus differential of partial differential of a cross b with respect to x. So it follows in that order. In here it's dot and we have this. In here it's cross and this is what it goes. 3. If you have of partial differential of a dot b, okay, partial differential of a dot b with respect to dy dx, then you can say that that is equal to dy of d dx in a dot b. Okay, so this is how it goes. So partial d of a dot b with respect to dy dx is equal to partial d dy of partial d dx of a dot b. Partial d with respect to partial dy into a dot partial db with respect to partial dx plus partial dA with respect to partial dA dot b with respect to x is equal to a partial the squared b over dy dx, okay, dy dx plus partial dA with respect to partial dy dot partial b with respect to partial x. So this third rule is ending up here. So basically, that is the end of the third rule. Okay, so these are the rules that governs partial differentiation of vectors. Please note them very well, and that is going to facilitate your understanding of partial differential of vector functions. So that is what we have here. This is the first one, the second one, and the third one. Basically, there are three rules that governs the partial differential of vector functions. Okay, so now let's look at some problems to clarify this concept. Okay, to clarify the concept of partial differential of vector functions. So the problem one says that if A is equal to this position vector and B equals this position vector, then we should find the partial of A dot B with respect to partial x, right? At the point -1, -1, -1. Okay, so we start, and the b also is going by partial of a cross b with respect to y at the point 1, 1, 1. Okay, so let's begin. So we have these position vectors a and b. Okay, and we have to find partial a dot b with respect to x. So what we need first is to find the a dot b. Okay, so dot of a and b first. That is what we need for the a part. So a partial dx of a dot b at -1, -1, -1. Okay, we have to find a dot b first. So a dot b is equal to the dot of the position vector a and that of b. So that is going to be xi minus xy j plus s squared yz k times yzi minus xzj plus yk. Okay, so we're going to multiply that, and we're going to have a dot b to be equal to xi times yzi becomes xyz. Okay, and xi times negative xzj becomes 0. Okay, xi times yk becomes 0. The reason why it's 0 is you are multiplying that with an opposite position vector I and j. Cross of dot of that is 0. Okay, and now we are done with the first set. Let's come to the second part. So negative xyj times yzi is also 0. Okay, and negative xyj times negative xzj is plus x squared y s squared y z x squared yz x squared yz. Okay, negative xyj times yk is also 0. And we come to the last term, s squared yz times yz gives us x, that is also 0. And x squared yzk times negative xzj also gives us 0. And s squared yzk times yk gives us plus x squared s squared y z. S squared y z. Okay, so we have the dot of a and b. So let's simplify that. So a dot b is equal to x y z plus x squared y z plus s squared y z. Okay, so basically we are going to have a dot b to be equal to x y z plus s squared y z plus s squared yz becomes 2s squared yz. Okay, so that is what we have basically. So yeah, that is x y squared z. From here, this and that is s squared. This and that s squared y squared. Okay, s squared y squared. So we have s squared y z plus s squared y squared z. Okay, so that is what we have. Okay, that is what we have. So now we can find the differentiation of this. Okay, so let's do that. So let's do that. So now we're going to have partial d with respect to x of a dot b to be equal to, we are going to differentiate this with respect to x. So that is going to be yz plus 2xyz plus 2xy squared z. Okay, so we have been able to differentiate a dot b with respect to x, and we are asked to find the that at -1, -1, -1. That means that x is equal to -1, y is equal to -1, and z is equal to -1. So we have partial with respect to x of a dot b to be equal to -1 times -1 plus 2 of -1 of -1 of -1 plus 2 of -1 squared of -1. Okay, so we're going to have -1 times -1 is 1 plus 2 times -1 is 1 times -1 is -1. So we're going to have -2. Okay. Then 2 times -1 is -2. Okay. And -1 squared is 1. Okay. Times -1. Okay. So we're going to have 1 minus 2 1 minus 2 plus 2. Okay, so basically we have this cancels this, and we are having 1 as our result. Okay, so all this we did, the result is giving us 1. So we have our partial d of a dot b with respect to x at the point 1, 1, -1, -1, and -1. The result is +1. That is interesting. So let's do the b part of a cross b with respect to y at the points 1, 1, and 1. Okay, so first we have to find a cross b. So a cross b A cross B will be equal to, we have two position vectors, right? So we're going to have our matrix for cross product. Once you hear cross product, begin to think about finding determinant. Okay, so we're going to have I, J, and K. So we're going to have X here. We're going to have minus XY here. We're going to have X squared Y. And then we're going to have Y, Z. We're going to have minus X, Z. And we're going to have Y here. So that is the matrix. Okay. So now we're going to use rule 1 as our operation rule. Okay, so we're going to find A cross B. So A cross B will be equal to I into, we cover, when you are considering this, then you are going to cover everything here, So the element left is negative XY, negative XZ, X squared Y, Y, right? And then you come here, negative J, then you cover everything on that row, cover everything under it, then you have X, Y, Z, and X squared Y, Y, right? And the last part, which is K of, you cover everything here, So we're going to have X, Y, Z, and negative X, Y, negative X, Z, right? So we're going to have our A cross B, to be equal to I into negative xy times y becomes negative xy squared. Okay, then minus xz times x squared y becomes negative x cube, negative s cube y z, right? But on the off diagonal, we have negative affecting it. So negative is going to be plus, right? Then we are done with that. Let's go to the j. Minus j into x times y is xy minus x squared y times yz is x squared y squared z. Okay, so we are done with the j section. Plus k into x times negative x z is negative x squared z minus yz times xy is xy squared z, xy squared z. Okay, and there is a negative there, so negative is going to be positive. Okay, so we have that here. So our A cross B is equal to negative um should we leave it like that or we should expand it? Okay, if we leave it like that, our differentiation is going to be something else. Okay, so let's try to expand that. So we're going to have negative xy squared I plus s cube yz I minus x y j plus x squared y squared z j minus x squared z k plus x y squared z k. Okay, so basically our A cross B is giving us minus x y squared I plus s cube y z I minus x y j plus x squared y squared z j minus x squared z k plus xy squared z k. Okay, so that is what we have. Now, we have to find the derivative of this with respect to y. So we're going to have, okay, so we can continue here. Derivative of a cross b with respect to y. So we're going to have, we are differentiating this with respect to y. So differentiating this with respect to y, we're going to have negative 2x y I, right, plus x cube s cube z I. Okay, then we come here with respect to y, we're going to have negative xj plus 2x squared y zj minus negative s squared. Okay, so this part, we don't have any y there, so that part goes to 0, right? So this part, there is no y here, so it's treated as a constant. So that part goes to 0. Then we come here, we're going to have differential of x y squared z k with respect to y is plus 2x y z k. Okay, so that is the differential of a cross b at, now we have a cross b, differential of a cross b with respect to y. So now let's find that at 1 1 1, at the point 1 1 1. So we're going to have at the point 1 1 1, at the point 1 1 1 means that our x is equal to 1, our y is equal to 1, and our z is also equal to 1. So we're going to have negative 2 into 1 of 1i plus 1 cube into 1i plus negative 1j plus 2 into 1 squared into 1 into 1j plus 2 into 1 into 1 into 1k. That's interesting. So basically, we're going to have this here, we're going to have here to be negative 2 times 1 is negative 2i, right? Then 1 cube times 1 is 1, right? So we're going to have plus I. And then minus j plus 2 squared plus 2 into 1 squared times 1 is plus 2j. Okay, then finally we're going to have plus 2 of 1 times 1 is plus 2k. So basically we're going to have that to be negative 2i plus I is negative I, and negative j plus 2j is plus j. Okay, and plus 2k. So at the point 1 1 1, we have the partial differential of a cross b with respect to y to be negative I plus j plus 2k plus b. Then we take the differential of that with respect to t to have the differential of a dot b with respect to t. So first, our question A, which is differential of a dot b with respect to t, we have to first find a dot b, okay? And that is equal to 5t squared I minus 5t squared I plus tj minus t cube k times sine t I minus cos tj here. So when you take the dot of this, you're going to have 5t squared I times sine ti is going to be 5t squared sine t. 5t squared times negative cos tj becomes 5t squared I times negative cos tj becomes 0. Two opposite unit vectors. When you find the dot, you get 0. Then you come here, the j. Tj times 5, tj times sine ti is also 0. Tj times negative cos tj becomes negative t cos t. Okay, then we come here, negative t cube k times sine ti becomes 0. Negative t cube times negative cos t j becomes 0 as well. So we're going to have our a dot b, right? So now we can go ahead and find the derivative of a dot b with respect to t. So we're going to have differential of a dot b with respect to t, right? And that is going to be 5t squared sine t. Differential of that, we have to apply the product rule here. So I told you that everything you learned from the basics is applicable here. So 5t squared sine t, we are going to apply the product rule. And it says that you differentiate the first one, maintain the second one, plus maintain the first one, differentiate the second one. So we're going to have differential of 5t squared is going to be 10t. Then we maintain sine t, right? Then we maintain 5t squared, then we differentiate sine t. And when you differentiate sine t, you're going to have cos t, right? Okay, now we come to t cos t. In that case, we will use product rule. So we differentiate t, maintain cos. So we're going to have negative 1 times cos t. Then we maintain negative t, then you differentiate cos t, and that is going to give us negative sine t. So we're going to have into negative sine t. So negative, this part will be positive. So we have sine t, right? So that is what we have. So over here, we can say that d of a dot b with respect to t is equal to 10t sine t plus 5t squared cos t minus cos t plus t sine t, right? And this, we can factor something out. We can share this one. We have common terms. This is a common term and this is a common term. So we're going to have 10t sine t plus t sine t plus 5t squared cos t minus cos t, right? So the sine, when we factor, it has t in common and it has sine t in common. So we factor the t out, and we're going to have into 10 plus 1, okay, multiplied by sine t, okay, plus the cos aspect, which is 5t squared cos t minus cos t. We can factor cos t out. So we're going to have into 5t squared minus 1, all multiplied by cos t. Okay, so that becomes the differential of a dot b with respect to t. We have t out, into 10 plus 1, right? So even this is going to add up, making 11, right? That is going to add up, making 11. So we're going to have differential of a dot b with respect to t will be equal to 10 plus 1, that is 11, t sine t, right? Then plus 5t squared minus 1 or cos t, right? So the final answer for a, the differential of a dot b with respect to t is equal to 11t sine t plus into bracket 5t squared minus 1 cos t. So that is it for the a part. The b said we should find the differential of a cross b with respect to t. Okay, I'll leave this part to you as an assignment. Please try and do the partial of a cross b with respect to t. Message me at the comment section. When you get it right, I'll provide the final answer. When you get it right, reach out to me. I'll have a bonus for you. Okay, so let's do the last one, which is the C. The C says that we should find the differential of A dot A with respect to T, right? So first we have to find A dot A, right? So A dot A is going to be 5t squared I plus tj minus t cubed k multiplied by itself, right? So we have A dot A to be equal to 5t squared I times 5t squared I will give us 25t to the fourth. Then 5t squared I times tj is 0. 5t squared I times negative t cubed k is also 0. Then we come here, tj times 5t squared I is also 0. tj times tj becomes plus t squared. tj times negative t cubed k becomes 0. Then we come to the last one, negative t cubed k times 5t squared I becomes 0. Negative t cubed times tj becomes 0. And then negative t cubed k times negative t cubed k becomes plus t to the sixth, right? So we have A dot A to be equal to 25 t to the fourth plus t squared plus t to the sixth, right? So here, now we can take the differential of A dot A with respect to t, right? So we're going to have that equals differential of 25t to the fourth is going to give us 100t to the third, right? 100t cubed plus differential of t squared is 2t. Differential of t to the sixth is plus 6t to the fifth. Okay, so this is the differential of A dot A with respect to t. That is great. So I leave this to you. Please try, and when you get it, reach out to me and I'll have a bonus for you. Okay, so that is the final answer. Let me provide the final answer for you. So the final answer for D, differential of A cross B, okay, with respect to T is equal to negative out 11t cos t plus 5t squared plus 1 multiplied by sine t or k. Okay, so that is the solution for differential of a cross b with respect to t. Negative into big bracket 11t cos t plus 5t squared plus 1 sine t or k. So try it out. When you get it, reach back to me and I'll give you a bonus. Okay. Thank you very much for watching. I really appreciate your time. Don't forget to subscribe, share with your mates, and I'm going to give you fantastic um, lessons more. Okay, bye.